I, um, I was listening backstage to the last two presentations, and I had two overwhelming feelings. One is just wow. Maria was a tour de force, wasn't she? Wasn't that spectacular? And the other thought I had is, why in the hell did I decide to speak after Maria? So bear with me a little bit. Maria talked and started her remarks really with the premise of, let's imagine where we'd be 30 years from now. And of course, we've got a lot of wood to chop to get through the next 30 years, and she talked about some of the key policy choices we need to make. But I think it all kind of begins with people, right? Making sure we continue to train the next generation of folks in this industry. And quite honestly, just looking out at the crowd of folks that we attract, it's just, I don't know about all of you, but it's just nice to see young people in the room again. 5 or 10 years ago, when the industry was really being challenged, and as Maria said, in places like Illinois, as recently as 8 months ago, I thought to myself, if people are the key ingredient, we know they are, then continuing to attract new generation of talent into this business is kind of fundamental to our success. And I would have described the nuclear business 5 years ago as an older person's business. That is, that the future wasn't particularly clear. But fast forward to now, the presentations you've heard this morning, not just from Maria, but from Katie Huff and the ambition for government, and it's clear to me that it is an industry that is as vibrant as any other. And while we present this as choices around nuclear, I think at the end of the day, the deeper we get into understanding the climate crisis and the steps that we need to take to combat the climate crisis, the more evident it will be that it isn't a choice. And oftentimes we talk about this as explaining why our technology is better than renewable technology or provides different resources. And I think sometimes it's a bit of a disservice to wind and solar for folks to assume that intermittent resources should be able to run an entire economy's electric system. It's not a criticism of them. Throughout the entire history, our 100+ year history in this business, we've never relied on just certain technologies. It's always been an all of the above approach, and it's going to have to be increasingly as we go forward. It's not a criticism of wind and solar, it's simply the reality. So what I'd like to just talk a little bit about is, Maria talked about 30 years from now. Let's talk a little bit about the challenges we face and how dire the circumstances are. I know there's a wide variety of views on the climate crisis, but this much is clearly known to us, that the last 10 years of weather have been hotter across the globe than the entirety of weather forecasting and weather records, right? Scientific weather records. They've been the 10 hottest years. And some folks would criticize that and say, look, we've only been really tracking weather in this country and across the globe for about 180 years, and that's true. But you don't have to be a statistical genius to figure out that if the 10 hottest years happened in the last 10 of the 180 that you've been tracking, something's happening. And we see that. It's evident. And we know that CO2 is a pollutant that tends to cause global warming. So I think the pieces are pretty well understood and pretty well put together. It's if you walked into this room not believing that the climate crisis is real, I'm not going to change your view in the next few minutes. What we can talk about is the steps that we've taken and the steps that we're going to need to take. Since the 1980s, we've reduced emissions fairly dramatically in the electric sector by as much as 30 to 40%, depending on the year you want to anchor from. And there really have been 3 acts in that play. The first act was about the nuclear industry. In the 80s and 90s, the machines that we have weren't being run particularly effectively. we had fleets, entire fleets like the Commonwealth Edison fleet, one of the largest in the country, that was operating at capacity factors that were slightly above 50%. And so as an industry, we fixed that, right? Today, we're operating at darn near 90% across America with these units that we have. That dramatically reduced emissions. The second act in the play has been shale gas. And while gas-fired generation clearly emits CO2, and some folks believe that the drilling emits even more CO2, the reality is we have seen, in terms of tailpipe emissions in our country, dramatic reductions as we've replaced coal plants with natural gas. Problem is, there's probably not much more oink in that pig, right? We've replaced largely all of the coal plants in many regions of the country. We're not going to get there. And the third part of this story is renewables and energy efficiency. Of course, energy efficiency being incredibly important, as we know that lighting and other things dramatically reduce electricity demand and, as a consequence, reduce pollution. So we've gotten to where we've gotten. That's great. And I'm pretty confident as I stand here that we're going to continue to do that. It's going to be harder to make efficiency gains. We've grabbed a lot of the low-hanging fruit, but we'll continue to do that. We'll continue to build out renewables. But while that sector of the economy has done better, the other sectors of the economy not so much. They've actually grown in emissions, whether it's transportation, industry, agriculture. We now see today that the emission increases from those sectors sometimes dwarf all of the great things we've accomplished in the electric sector. And so increasingly we're thinking about sector coupling, right? How do we take the electric sector, where we're continuing to increase clean and renewable energy production, and couple that to other sectors of the economy that traditionally operated on different fuels? I think that's an important opportunity for us to talk about. But the truth is, while we've made a lot of progress and we appropriately herald that progress, we've got so much more to do to be able to reduce emissions to zero in these other sectors of the economy. And when you put that together with the reality that for all of us that are in developed nations, and you might want a boat or you might want to whatever you want to buy next, you're sitting in a country with great wealth, and we are incredibly lucky to be here. And for all the developed nations, there are 6 people behind each person in a developed nation that want everything you have. They want all the stuff in the transportation sector, the industrial sector, agriculture. They want to feed their family, all of those things. And when you put those pieces together, you start to understand just how difficult this task is going to be in front of us. And I have no doubt that we will build small modular reactors and that the next generation of nuclear will come, because it has to. It's simply a mathematical reality to meet this challenge, to couple all of the sectors to the electric sector, empower industrial processes, do the things in agriculture and transportation to electrify. We're going to need a lot more electricity, and it's not just going to come from intermittent resources. That's just the reality of it. So this vision that Maria articulated incredibly well is not a vision that I think has a lot of question marks around it. It's just simply what we have to do. And we're fortunate in this country to have the dough to be able to do it. We use and have used tax credits for a long period of time to build the renewables, but make no mistake, that's real money that's come from the US Treasury. These other developing countries, they don't have those sorts of resources that we have in our balance sheet as a nation, and so they're going to need the cheapest and most reliable technologies. And I think at the end of the day, in that beauty contest, small modular reactors are going to do incredibly, incredibly well. So we're in an industry that is, I think, inevitably going to grow, but we've got to also figure out what we're going to do with the existing machines. That's where we've spent a lot of time, quite naturally, at Constellation. We own 23 nuclear units around the country, and we've fought for our survival for the past 5 or 10 years in the merchant business. I won't kid you. As compelling as it is to say, look, to power all of these other sectors of the economy, we're going to need 500 to 1,000% more clean and renewable electricity than we have today. We're going to have to do that in 27 years as we phase out all other known generation resources. And we've been having this, I think, silly conversation about whether we need the nuclear units we have. That's, hopefully yesterday's news, right? State after state has made the decision to preserve these units, and we now are here in a moment in time where the federal government is finally, at long last, putting nuclear on equal footing with renewables in terms of tax credits and support. And hopefully all of that comes to pass. So it's exciting, but we need to be able to do more with the fleet. The first thing that I think we have to come to terms with is how we measure success. You're all in the business, so kind of situational awareness is important to you as you run our wonderful machines. What's happening? What do we need to do, right? Situational awareness. In our clean energy work, I'm not sure we're situationally aware. And I'll explain it to you this way. From the beginning of time in our business, we've matched electric generation with consumption, right? That's the basic building block, basic engineering principle of operating a grid, is you have to have power wherever and whenever on the grid that our customers need it to run the stuff that they want to run. As we've built out a clean energy economy, we've disconnected from that reality, right? And so we have, all of you have probably passed by the places that are running a night shift and they claim to be 100% renewable because they have solar panels on their roof. And you're like, what, really? We have a lot of work that's been done where companies claim to be 100% clean, and they're sitting in South Carolina and they're buying RECs, renewable energy credits, from West Texas wind, which is not electrically interconnected, as we all know, as a result of the last year's events, with the rest of the grid, and they're pretending to be clean. It's not real. It's not the way we run the grid in reality. In reality, we have to have electric production near to the site it's being used, geographically interconnected, and happening simultaneously with that. The further we get into the climate crisis, the more we run the analytics, the more real we have to be about how we measure things. So at Constellation, one of the efforts that we are working on with the federal government and others is to ensure that when customers say that they are clean, that they're actually clean, that they're not using wind that was generating in April and pretending that it's available in August to run their facilities. And so load matching becomes important. President Biden signed an executive order earlier this year requiring the federal government by 2050 or by 2030 to demonstrate that at least 50% of the energy it uses is load matched in time and geography. That's really important for us to talk about. I heard a question about how we talk about this business. We've got to measure it the right way in the first place. Load matching becomes really important to us. For us at Constellation, not only are we the largest nuclear operator, but we are also the largest retailer of electricity and natural gas to 75% of the Fortune 100 companies in the country. And they're moving their businesses and their ESG goals from just buying RECs to buying a product that is load matched, that the energy comes at the time it's needed. That's really important to this nuclear discussion. We've got to break some of these fictions to see very clearly what we're up against. So that's one thing. I think the second thing we need to do as an existing fleet is to reimagine our sites. At Constellation, we're not going to call our plants nuclear plants anymore. They will become clean energy centers with fundamental changes to the strategic approach. One of those changes is bringing load behind the fence line of the plants. We have some incredibly unique advantages at the nuclear sites. We have plenty of land. We have access to water for cooling for other industries, but also for hydrogen production to the extent that we decide to do that. We have waste heat. We know in the case of electrolysis and hydrogen production that the hotter we could get the liquid before we run it through an electrolyzer, the more efficient that process becomes. So the steam and the waste heat that is produced by a nuclear plant that has been heretofore a problem is an opportunity as we think of making hydrogen behind the fence line. At all of our plants, we have rail lines or access to big water so that we could move the fundamental products that we make with hydrogen. The economy, as we get to sector coupling, is going to require a common fuel. Electricity being one of those fuels, but we're going to need drop-in fuels for aviation, for trains, for industrial processes that run in their existing engines. So at Constellation, we're working with the nation's largest air carriers to produce sustainable aviation fuel behind our fence line. Sustainable aviation fuel in the form of ethanol or methanol, which could quickly be converted into the kerosenes that burn in existing engines. Ethanol, folks, is just simply clean hydrogen and CO2 mixed together in a chamber, and you could create this simple alcohol, which all of you presumably know as a drop-in fuel today for transportation in light-duty vehicles. We will make that at our clean energy centers. Other things like Tier 0 data centers, which are exploding around the country as computational needs increase, could be housed behind the fence line of our plants and enjoy the kind of reliability at a dual unit station that they could get on the grid. Because as a general matter, one of the two units is always operating, right? Only one's going to be refueled at a time, and so you could provide a level of reliability. And the advantages they have is that they don't pay any big utility transmission or distribution charges. So as we go forward, we'll look at all of these opportunities, making clean hydrogen and all these other byproducts, housing Tier 0 data centers. We announced our first 300 megawatt data center in Texas as a fleet not too long ago. And we will also work on technologies to actually scrape CO2 from the air. And so recently, working with Katie Huff and her department, we earned a DOE grant to use an innovative new membrane developed by Occidental Chemical that we actually put in our cooling tower. And the way this works is there's an organic additive added to the cooling water. That attracts CO2 as it goes up a cooling tower, and then that gets trapped in the membrane. We take that membrane out, and we extract the CO2. That CO2 could then be used to make sustainable aviation fuel in the manner I described earlier, and the whole process is net zero. Yes, the jet will burn that fuel and emit CO2, but it will be the same CO2 that we captured earlier. So from a net standpoint, it's zero emissions, and we could decarbonize that sector. Same thing could be done for fertilizers by creating ammonia, which again is just the combination of hydrogen and nitrogen scraped from the air, and a number of other products that right now are developed in the petrochemical industry that will be made at our clean energy centers. So as you cast your eyes towards the horizon and you listen to all of the great advancements on SMR technology, I don't want you to forget the important and continuing role that we have as existing fleet operators. We have to run these machines to 80 years. We need to make sure that the NRC goes through the EIS process, the environmental impact statement process review that they're going through, and allows these plants to continue to operate for 80 years. That will create a career path forward for the young folks that are in this room and many more that we need to attract into this industry. We need to do more with our existing sites, including bringing some of these industrial processes behind the scenes. And sometimes we may add wind and solar behind the fence line of a nuclear plant. Why? Because we're going to have a lot more consumptive load at the nuclear plant in the form of sustainable aviation fuel or other production methods. So we need to kind of think about rebranding the technology and doing more for America than we're presently doing. This will solve some of the challenges that we've faced in the last 5 to 10 years, where we've had an overproduction of clean energy at certain moments in time seasonally, which have been a drag, an economic drag on our existing nuclear fleet. Now we will have a place to put that excess energy that will not require turning down the nuclear plant, feathering the wind farm blades, or turning off the inverters on solar panels. We've got to figure out how to handle this seasonal overproduction that we will have and use that power for good things rather than turning off the power so we don't burn up the lines. This is the stuff that we're going to work on. We'll be working on this with many of the partners that are presently in the room. And I think it's an incredibly exciting future for the young folks that we're bringing in to not only know that we're going to continue to support the grid when the grid needs electricity, but we will create fuels that we'll use to decarbonize industry, agriculture, and heavy transportation, that we will have the clean energy to support a new growing sector of the economy in terms of data centers, and that we will actually be able to scrape CO2 from the air and not just become zero, right? Zero isn't the goal. We're going to have to extract CO2 using our facilities because we're going to have to do better than everyone else because there will always be parts of the economy that I'm afraid we're going to have a heck of a hard time decarbonizing. So that's our Clean Energy Center vision. The two things I want to leave you with is we've got to be honest in this conversation about how we measure our success. Where are we at any moment in time is not based on the total clean energy you produce in a year and comparing that to the total load you have. But like for the last 120 years of our business, an understanding second to second of whether we're using fossil fuels and whether we have the resources, that will undoubtedly favor the technology that we operate and call attention to policymakers for its need. It will simultaneously eliminate some of the greenwashing that is occurring out there. That's what the SEC is working on. We should support those rules as an industry. We should insist that people measure appropriately. And the second thing is, while we look at the horizon and we look at the next 10 years and the coming generations of SMR technologies, don't lose sight of the importance of the machines that have served America for decades and are poised to serve it for many more decades to come. So with that, let me thank you all for your time. Have a wonderful meeting here. You kicked it off with two fabulous women speakers, which is pretty exciting. And I hope you are compelled to action by Maria's comments, because I just want to leave you with this. You are our best ambassadors. She made a point that you got to get out there and talk about the business and talk about the technology. Folks in the renewables business do that every single day, and we have to do that. A lot of times in the history of our industry, we've kind of run silent and deep. This isn't the moment in time to do that. So I hope you'll join me in being an advocate for the great things we all do. Thank you so much.